Good afternoon, Doctor. My name is Yean, metric number U2104524. Today we will be presenting how to use C++ and MATLAB to solve three sets of linear equations by using Gauss elimination methods.
Hi Doctor, my name is Hui Ping, metric number 22004631.
Hi sir, my name is Wilson, matrix number 22004691.
Greetings, sir. My name is Ryan Chang Boon, matrix number U210353G/2.
Greeting, Doctor. My name is Cheong Ziyang with matrix number 22004664. Let us embark on a journey into the realm of linear algebra, where we delve into the venerable Gauss elimination method. This classical technique, developed by Carl Friedrich Gauss in the 19th century, stands as a cornerstone in the solution of linear system of equation, with applications spanning science, engineering, and computing. Notably, Gauss elimination is not confined to manual calculations. It also unfolds its potential through computational approaches in the languages like C++ and MATLAB. Our exploration begins with an examination of theoretical landscape of Gauss elimination, firmly rooted in the fundamental principles of linear algebra. Envision a augmented matrix where A signifies the coefficient matrix, X represents the vector of unknowns, and B stands for the right-hand side vector. Through a sequence of elementary row operations like adding or subtracting rows and pivoting, Gauss elimination transforms these metrics into a more manageable row echelon form. This systematic process paved the way for back substitutions, ultimately yielding solutions for the unknown variable. And for the problem statement is to determine how C++ and MATLAB are used to solve non-homogeneous system of three sets linear equations matrix by using Gauss elimination method, and to determine what concept we use in C++ and MATLAB, and lastly to compare the coding between C++ and MATLAB.
Now I'll talk about the methodology part. This part consists of two components, flowchart and pseudocode for both C++ coding and MATLAB coding. Flowchart is a diagrammatic representation of an algorithm, while pseudocode is a way of describing the distinct steps of an algorithm in an easier way for anyone to understand. There are many symbols used in flowchart of programming and coding. For instance, the flow line indicates the flow of logic by connecting symbols, and the terminal represents the start and the end of a flowchart. The other symbols represent different functions with each other. Let's begin with the flowchart and pseudocode of C++ coding. Left side is the flowchart, while right side is the pseudocode. The flowchart begins with start, followed by several declarations of variables. We also display the phrases, "Welcome to Gauss elimination method calculator" in the beginning. Next is the use of a nested for loop, consisting of a while loop and an if-else loop for the user to input the coefficient matrix. A reminder will be outputted if the user enters the wrong input. Next, a nested while loop is used to prompt the user to enter the source matrix. A reminder will be outputted once the user enters the wrong input. Then the function display matrix will be executed to display the augmented matrix entered by the user. The pivotization function will then be executed inside the for loop to pivot or arrange the matrix before Gauss elimination. The pivotized matrix will be displayed again. After pivotization, the Gauss elimination function will take place. The calculation will be operated and the matrix after Gauss elimination will be displayed. The last function is the back substitution function that will show the values of each variables line by line. A reminder of no solution will be shown if the matrix entered by the user have no solution. Next is the methodology for MATLAB. It is basically the same as C++ at the beginning. After starting, the user will be prompted to enter the coefficient matrix and the source matrix. The augmented matrix will be displayed and stored. Then the pivotization is executed in a for loop statement, and the matrix after pivotization is displayed. Next is conducting forward elimination in a nested for loop, and the matrix after forward elimination is displayed. The last part is to perform the back substitution in a for loop statement. The solutions of the system will be displayed line by line.
So for the manual calculation, we apply the pivotization process and the forward elimination to obtain the augmented matrix. After that, we apply the back substitution to obtain the unknown values, which was x1 equal to 3.7500, x2 equal to negative 3.0682, and lastly x3 equal to 4.2045.
So now I'll explain about the plus coding. So in the coding, we have used four functions, which is void display matrix, which to display the matrix, and void pivotation to carry out pivotation, and then we have Gaussian elimination, and lastly we have back substitution. And as you can see here, this is the coding for each function. Inside the initial main, first we set the output to be 4 decimal places, then we use the for loop and nested while loop to enter input inside the matrix inside the array. As next, we also use if else statement to make sure that the user input are valid, which is number. And if the user enters something other than number, it will let the user know that the input are invalid and ask them to re-enter the input. This is the same coding as just now, but it is for entering the source of the equation. So after the user input their matrix, first we will display out the matrix as you can see in the output, which is the enter augmented matrix. Next, we will use follow again. Instead of follow, we'll use the pivotization functions, and we'll display again the matrix after the pivotizations. And then we will use the Gaussian elimination function to let the matrix undergo Gaussian elimination and display again the matrix. Lastly, we'll use the back substitution function to back substitute the value inside the matrix. Then we will print out the value of x, y, z. And just in case that there is no solutions, it will print out there is no solution.
Now I will present the MATLAB coding. Basically, MATLAB has the same process as C++, but it allows user to input the matrix directly for faster computation. The first line will display the sentence "Welcome to Gauss Elimination Method Calculator." Then you will insert your coefficient matrix and your source vector, which is shown in the slide. After that, the augmented matrix will be shown in the command window. The first loop is utilized to do partial pivoting by finding the maximum absolute value in the current column. The pivoted matrix will be shown in the command window. Then the next loop is used to do forward elimination for a current column. The augmented matrix of forward elimination will be displayed. The iteration continues to the next column. Then the command window will display the augmented matrix after completing the forward elimination. Line 34 will perform back substitution for the last row of the augmented matrix, and the answer is 4.2045 is displayed in the command window. A loop is performed to conduct the back substitution for the remaining row in reverse order. So you will get x2 is equal to negative 3.0682 and x1 is equal to 3.7500, which is shown in the command window. The answer obtained are accurate to 4 decimal places.
Based on the similarities of both codes follow the same fundamental steps of Gaussian elimination with partial pivoting to solve a system of linear equations. They include procedures for matrix display, pivotization, Gaussian elimination, and back substitution. Besides that, both codes involve user input for entering the coefficient matrix and the source vector, providing a dynamic way to input the system of linear equations. Other than that, both codes include statements to display intermediate matrices at various steps of the Gaussian elimination process. This helps the user to visualize the changes in the matrix during the solution process. Lastly, both codes include some level of input validation, ensuring that the user enter valid numeric values and prompting them again if any invalid input is detected. In terms of the differences, the syntax of the two languages are different. For example, the array indexing, loop structures, and function calls have distinct syntax in C++ and MATLAB. Besides that, MATLAB provides more convenient matrix manipulation capabilities, simplifying certain operations like matrix concatenation. In the MATLAB code, the augmented matrix is created by directly concatenating the coefficient matrix and the source vector, whereas in C++, a separate display function is used for the augmented matrix. Other than that, the way the results are displayed to the user differs. In C++, a fixed width of 16 is specified for displaying matrix element. In MATLAB, on the other hand, the display function is used to display the matrices and vectors without specifying a fixed width. Lastly, C++ coding is coded to only solve 3 sets of linear equations, while the MATLAB code can solve many sets of linear equations. After applying both coding methods, we find that MATLAB is easier to code as compared to C++ for the Gaussian elimination method. This is because MATLAB is particularly well suited for the matrix and array of operations, which are fundamental in many scientific engineering applications. It is possible to conclude that there was no error in our coding, as the results of the manual calculation was tally with the results we obtained from C++ and MATLAB.